Hey folks, I wanted to give you a run through of using trigonometry to solve for a real world problem. So in this problem, we are going to use a theodolite to measure our angle, and we are going to use trigonometry to solve for the height of the building. Now, you can see that as we're taking this shot, we are going to have to also add on the height of our instrument to get the total height from the ground up. Which, I mean, certainly beats having to like try to hook up a tape up here and hang it down. Now, just before we get started, to remind you that when we are using precise survey instruments like a theodolite, what we'll use is degrees, minutes, and seconds. So just a reminder that within each degree, 1 degree equals 60 minutes. That's how we write it, like just like the feet number. And then within each 1 minute, there are 60 seconds. Okay, so same notations as feet and inches, but they mean something different in this case because we're dealing with an angle. So I'll show you how this works. It really isn't complicated, but it's kind of like converting inches and feet, back and forth, back and forth. So let's have a look. So we can see here that we are, from the perspective of the theodolite, we are going to be working with our opposite side and our adjacent side. So because we're using opposite over adjacent, the formula we're going to use is going to be tangent, okay? So tan of our angle is equal to opposite over adjacent, okay? Now, our angle, this is not going to go into our calculator unless you happen to have a DMS button on your calculator, which is degrees, minutes, seconds. So because I'm using my computer calculator, I do not have, unfortunately, a DMS button. Okay, let me just clear the screen here. So what we have to do is convert this into just decimal degrees. Okay, so 26 seconds, we're going to go 26 divided by 60. And that's 0.433333 minutes. So we'll add on our minutes, we'll go plus 15. So now it's 15.4333 minutes. So you can see we're just kind of working our way this way. And now there's 60 minutes in a degree. So we're going to divide that by 60 again. And then we'll add on our 31 degrees. So now we have an angle of 31.2572222 degrees. Okay, so you can see just a more precise way of measuring that angle, and that's how the readout on the theodolite works out too. So if we look at our formula, okay, we have tan of our angle is equal to opposite over adjacent. So opposite is the unknown side, adjacent is 24.5 feet. So we're going to go tan of 31.25722 degrees is equal to opposite over 24.5 feet. Now, here's a little trick that I like to use. If this were 45 degrees, the rise and the run would be the same. And so because this 31 degrees is less than 45 degrees, the overall height on this side should be less than 24.5 feet. So we know that whatever we do to the 24, the answer is going to have to be smaller. So here's my angle, and what we're going to end up doing is we're going to bring the 24 across the equal sign. And when we do, since it's being divided here, it's going to end up becoming multiplied. So we're going to go tan, I'm going to hit the tan button here, of the 31 point, et cetera, et cetera. Okay, and then we're going to go times 24.5 feet gives us our opposite side is equal to 14.8712 feet, whatever. So it's 14 feet. Okay, so 14 feet, and now I'm going to go minus 14. And so this is decimal feet. So we can take that number and go multiplied by 12 to put it into inches. So that's 14 foot 10. And then I'll take the 10 away, and then we'll get our fractions here. So I'm going to just go to the an accuracy level of sixteenths times 16, and that's 7/16. So 14 foot 10 and 7/16. So now what we have to do is we have to add on to the 14 foot 10, we got to add on 5 feet. Okay. So what we can do is, well, 3/4 is 12/16. So we can go 12/16. So if I go 7 plus 12, right, divided by 16, 19/16 is 1 3/16. Okay, so that's going to be 1 3/16. Now we can also add on our 10 inches and our 4 inches. Let's go plus 10 and then plus 4. Okay, so that's 15 3/16. Well, 15 is 12 inches plus 3. It's 1 foot 3. So what we're going to do is add on our feet together. So 14 plus 5 is 19 plus an extra 1. So it's going to be 20 feet. And what's remaining is 3. So I'll take the 12 inches off of that because we've added that on to go from 19 to 20. So we're going to have 20 foot 3. And just to prove, minus 3, and we'll go times 16, is going to be 3/16. Okay? 20 foot 3 and 3/16 is the total height from the ground to the top of that wall. All right, guys, I hope you find this helpful, and hopefully we get to practice our theodolite in the shop. Take care.